Hello everyone, I will solve different problems in motion in 2 dimensions. So let's start here. At t equals 0, a particle leaves the origin with a velocity of 9 meters per second in the positive y direction and moves in the xy plane with a constant acceleration 2I hat minus 4j hat meter per second square. At the instant the x-coordinate of the particle is 15 meters. What is the speed of the particle? So here's the situation. A particle is moving with acceleration, x and y accelerations, and the x-coordinate for the particle is 15 meters. Now we look for the speed of that particle. Now let's solve this one here. X final equal to x initial plus the initial t plus half ax t square. Now starting from origin and starting from rest, so both equal to 0. So x final here it's 15, it's given, equal to half ax it's 2 times t square, and from this one here t equal to square root of 15, or in other words t equal to 3.87 seconds. The final x equal to the initial x plus a t, again it is 0. Now ax here equal to 2 times square root of 15, in other words equal to the final x equal to 7.74 meter per seconds. Now the final y equal to the initial y plus a yt, in other words the final y equal to 9 plus minus 4, this is the ay here, it's minus 4 times 3.87 the time, and the final y equal to minus 6.48 meter per seconds. Now v as the magnitude or the speed equal to square root of 7.74 square plus 6.48 square, or 59.9 plus 41.99, or v in this case equal to 10.1 meter per second. A particle starts from the origin at t equals 0 with a velocity 6I meter per second and moves in the xy plane with a constant acceleration of minus 2I hat plus 4j hat. At the instant the particle achieves its maximum positive x-coordinate, how far is it from the origin? Now here's the situation. We have here a particle moves with velocity in the equal to 6I hat and moving in the xy plane like this one here. Now the acceleration is constant and ax equal to minus 2, ay equal to 4. Now the question is, how far is it from the origin for that particle? So a here equal to minus 2I plus 4j hat, and v equal to 6I hat. The final equal to the initial plus 2a delta x. In this case it's x final because the initial position is at origin. Now final position velocity equal to 0, so it's equal to 36 plus 2 minus 2 x final all equal to 0, and from this one x final equal to 9. Now y final equal to y initial plus v initial t plus half a t squared. This is 0 and this is 0. So y final, it's equal to half a t squared. So x final equal to x initial plus the initial t plus half a t square, and this is 0 right here. So it's equal to 6t plus half minus 2 times t squared, all equal to 9. This one here, we just calculated this one from this one here. You solve this quadratic equation and you will find minus t squared plus 6t minus 9 equal to 0. You solve this one here, t will be equal to 3 seconds. Now back to this equation here, y final equal to half ay t squared. You substitute t equal to 3 and a equal to plus 4, so it's equal to half 4 9 or equal to 18 meters. So the position here are equal to square root of 18 square plus 9 square or equal to 20 meters. A particle leaves the origin with a velocity of 7.2 meters per second in the positive y direction and moves in the xy plane with a constant acceleration of 3I hat minus 2j hat. At the instant the particle moves back across the x-axis, y equal to 0, what is the value of its x coordinate? Now to solve this one here, let's start with equations of motion. Y final equal to y initial plus the initial y plus half a t squared. Since it starts from the origin, this one here, and back to y equal to 0, this one is equal to 0 as well. So it's equal to 7.2 t plus half minus 2 t squared. In other words, 7.2 t equal to t squared, or t in this case equal to 7.2 seconds. Now x final, the final position here, equal to x initial plus the initial xt plus half a t squared. This is 0 and this is 0 as well. You substitute this back from this one here, you will get x final equal to 77.76 or almost 78 meters. At t equal 0, a particle leaves the origin with a velocity 5 meters per second in the positive y direction. Its acceleration is given by 3I hat minus 2j hat. At the instant the particle reaches its maximum y coordinate, how far is the particle from the origin? Now again, the initial y, in this case, it's equal to 5 meters per second, and ay is given here equal to minus 2 meters per second square. Now v final y square equal to the initial y square plus 2a delta y, or equal to 5 square plus 2 times minus 2 y, so 25 over 4 equal to y. In other words, y equal to 6.25 meters. Now y final equal to y initial plus the initial y t plus half a t square. You substitute this back in here, so 6.25 equal to 5t, this one 0, plus half minus 2t squared. In other words, minus t squared plus 5t minus 6.25 equal to 0. You solve it, you will find t equal to minus 5 plus minus square root of 25 minus 25 divided by 2, or in this case t equal to 2.5 seconds. Now x final equal to x initial plus the initial xt plus half a t square. Ax equal to, in this case, 3, and t we just calculated this one, 2.5 seconds, and this is 0 and this is 0 as well. So x will be equal to 9.4 meters. Now the final position r, in this case, it's equal to square root of 9.4 square plus 6.25 square. You do the math, you will find the position r, or the final position, it's 11.28 meters. A particle moves in the xy plane with a constant acceleration given by a equal to minus 4 j hat. At t equals 0, its position and velocity are 10 I hat meters and minus 2 I hat plus 8 j hat meter per second, respectively. What is the distance from the origin to the particle at t equal to 2 seconds? Since it's asking about the distance from the origin, we need to find x and y coordinates here. So x final equal to x initial plus v initial x t plus half a t square. From the given information here, it's no acceleration on the x-axis as given here, and x final in this case equal to the initial position, it's 10, this one here, plus the initial velocity, it's minus 2, times the time, it's 2 seconds. You substitute this one, x final in this case equal to 6 meters. Now to find the y final, follow the same rule, y initial plus the initial y t plus half a t square. Now the initial position y equal to 0, it's mentioned right here in the question, and 8, the initial velocity, it's 8, this one here, times the time, it's 2, plus half the acceleration on y, it's minus 4, times the t square, so 2 square, it's 4. You do the math, you will find y final equal to 8 meters. So the distance d is actually square root of 6 square, this one here, plus 8 square, or d equal to 10 meters. A particle starts from the origin at t equals 0 with velocity 16I minus 12j and moves in the xy plane with a constant acceleration a equal to 3I hat minus 6j hat. What is the speed of the particle at t equal to 2 seconds? The final x equal to the initial x plus ax t. You substitute the acceleration and initial velocity, so you'll get the final x equal to 16, it's given right here, plus ax, it's equal to 3, times the time 2, so it's equal to v final x equal to 22 meter per seconds. Now v final y equal to the initial y plus ayt. Again, you substitute the numbers, you will get minus 12 is right here, this one here, plus ay, it's minus 6 times 2. You substitute this, you will find final y equal to minus 24 meter per second. Now, the speed equal to the square root of 22 square plus 24 minus 24 square, or equal to square root of, or equal to 32.6 meter per second. At t equals 0, a particle leaves the origin with velocity 12 meter per second in the positive x direction and moves in the xy plane with a constant acceleration of minus 2I hat plus 4j hat. At the instant the y coordinate of the particle is 18 meters, what is the x coordinate of the particle? Now, to solve this one here, we need to calculate the x coordinate of that particle. So let's find y final equal to y initial plus the initial y t plus half ay t square. Now this is 0 because start from the origin, and start from rest, this is 0 as well. So 18, this is y final position, equal to half 4 t square. In this case, you substitute this, you will find t equal to 3 seconds. Now, the final position on the x-axis equal to x initial plus the initial xt plus half minus 2 3 square. This is 0 because start from origin, so 12 times 3 minus 9, and in total the final position x equal to 27 meters. The initial speed of a cannonball is 0.2 kilometers per second. If the ball is to strike a target that is at horizontal distance 3 kilometers from the cannon, what is the minimum time of flight for the ball? Now, to solve this, the horizontal distance x final equal to x initial plus the initial t, and remember in projectiles motion no acceleration on x, so ax equal to 0. So x final, it's already given 3 kilometers, so 3000 meters, and x initial starting from origin, so it's 0 plus the velocity here of the cannonball, it's 200 meter per second times t. You solve this, you will find t equal to 15 seconds. So the flight time is actually 15 seconds. A ball is thrown horizontally from the top of a building 0.1 kilometer height. The ball strikes the ground at a point 65 meters horizontally away from and below the point of release. What is the speed of the ball just before it strikes the ground? So here's the top of the building right here, and the height of this building, it's 100 meters, and the ball is thrown horizontally like this. Now, at a distance 65 from the base of the building, this one here, it strikes the ground. The question, what is the speed just before it strikes the ground? Now, to solve this one here, use the information on y to find the time, substitute the time back in the x information, and you will get the velocity there. Now, y final equal to y initial plus the initial t minus half gt square. So 100, this one here, equal to half 10 t square. Now this is 0 and this is 0 as well. Now this one is 100. You solve this, t equal to 4.47 seconds. Now the final y equal to the initial y minus gt. This is 0 and you substitute t and g in this case. So the final y equal to 44.7 meter per second. X final equal to x initial plus the initial x t. Again, this is 0. So the initial x equal to the final x, because acceleration on x is equal to 0, so velocity is constant, so it's equal to 65 divided by 4.47 or 14.5 meter per second. So v in this case it's equal to square root of 14.5 square plus 44.7 square. So v in this case almost 47 meter per second. A baseball is hit at the ground level. The ball is observed to reach its maximum height above ground level 3 seconds after being hit and 2.5 seconds after reaching this maximum height. The ball is observed to barely clear a fence that is 97.5 meters from where it was hit. How high is the fence? Now, here's the situation. V final y equal to the initial y minus gt, or in this case, the final y it's equal to 0 at the maximum height. So the initial y equal to 10 times 3 or equal to 30 meter per second. Now, v final square equal to the initial square minus 2g delta y. We need to find here the maximum height. So in this case, this one is 0. So delta y equal to 900 divided by 20 or 45 meters. Now to calculate the fence height, let's find y equal to vt minus half gt square or 30. Now the time is, remember, it's symmetric equation. So if we throw the baseball like this one here, it takes 3 seconds to reach the maximum height and another 3 seconds to reach the ground. But in this case, it takes 3 seconds to reach the maximum height, and the fence, it hits the fence right here, this one here, at t equal to 0.5 seconds or t equal to 5.5 seconds. So it's either 0.5 or 5.5 seconds. Both will get the same answers. So t in this case, it's 0.5 minus half 10.5 square or 15 minus 1.25 equal to 13.4 meters. So the height of the fence is 13.4 meters. Now to double check the answer, if we substitute the time, rather than using 0.5, we use 5.5. So in this case, y in this case equal to 30 times 5.5 minus half g 5.5 square, 165 minus 151. So the answer is 13.4 meters. A rock is projected from the edge of the top of the building with an initial velocity 12.2 meters per second at an angle of 53 degrees above the horizontal. The rock strikes the ground a horizontal distance of 25 meters from the base of the building, assuming that the ground is level and that the side of the building is vertical. How tall is the building? So in this case here we have a building unknown with unknown height, building Y here, and the ball strikes this way here with initial angle equal to 53 degrees. Now the ball hits the ground 25 meters from the base of the building here. Now we need to find the height of that building. From the information of x, we need to calculate the time and substitute that time back in the y equations. So x final equal to x initial plus the initial x t. Now x final is 25 meters equal to x initial, assuming this is the origin here, 0, and v initial x is the x component of this velocity, so 12.2 cosine 53, this one here, times the time t. You solve this, you will find t equal to 3.4 seconds. Now you substitute this time back in the y equations to get the height of the building. So y final equal to y initial plus the initial y t minus half g t square, and this is 0, equal to y initial plus 12.2 sine the y component 53 times 3.4 minus half g, it's 5, times 3.4 square, or 0, equal to y initial plus 33.127 minus 57.8, or y initial equal to 24.6 meters. A projectile is thrown from the top of a building with an initial velocity 30 meters per second in the horizontal direction. If the top of the building is 30 meters above the ground, how fast will the projectile be moving just before it strikes the ground? So let's draw the situation here. Here's the cliff or the building. It was 30-meter height, and the ball is horizontally fired with 30 meters per second, and it hits the ground right here. Now the question, how fast will the projectile be moving just before it strikes the ground? So it asks actually about the velocity just before it strikes the ground here. So the final x equal to the initial x. Remember, this is projectile, no acceleration on the x-axis whatsoever. In this case, it's equal to 30 meters per second, and no initial y component. So y final equal to y initial plus the initial y t minus half g t square minus 30 equal to minus half 10 t square, or in other words, t, this is 0, equal to square root of 6, or 2.45 seconds. So the final y equal to the initial y, which is 0, minus gt, or v final y equal to minus 10 times 2.45, other words minus 24.5 meter per second. So the speed equal to square root of 900 plus 600, this one right here, or square root of 1500, or 38.7 meter per second. A rifle is aimed horizontally at the center of a large target 60 meters away. The initial speed of the bullet is 240 meters per second. What is the distance from the center of the target to the point where the bullet strikes the ground? Now to solve this one here, x final equal to x initial plus the initial x t, and x final is 60 meters equal to, this is 0, assuming that starting from the origin, 240 times t, in other words, t equal to 0.25 seconds. So y final equal to y initial plus v initial y t minus half g t square. So y final equal to minus half 10.25 square, or equal to 0.31 meters or 31 centimeter. A rock is thrown from the edge of the top of a 100-foot tall building at some unknown angle above the horizontal. The rock strikes the ground a horizontal distance 160 foot from the base of the building 5 seconds after being thrown. Assuming that the ground is level and that the side of the building is vertical, determine the speed with which the rock was thrown. So the situation is as this one here. So ball is thrown with unknown angle, this theta right here, and this is v, that's what we are missing. And after 5 seconds, it strikes the ground 160 foot, and the height of this building is 100 foot. We need to find this v. So y final equal to y initial plus the initial y t minus half g t square. X final equal to x initial plus the initial x t. In other words, 160 foot equal to the initial x times 5, which equal to 32 foot per second. And remember, you have to convert g equal to minus 32 foot per second square. Minus 100 is my equation right here, equal to, this is 0, the initial y t minus half g t square, and minus 100 equal to 5 the initial y minus half, and remember g equal to 32 foot per second square. So it's 32 times 25, it's 5 square, So the initial y, you solve this one here, you'll find it's equal to 300 divided by 5, or the initial y equal to 60 foot per second. So the value or the speed v here is actually equal to square root of this one square, 32 square, plus this one square, 60 square. Other words, v here equal to 68 foot per second. An airplane flies horizontally with a speed of 300 meters per second at an altitude of 400 meters. Assuming that the ground is level, at what horizontal distance from a target must the pilot release a bomb so that to hit the target? So the situation as this, we have a plane right here and moving with horizontal velocity 300 meters per second. So the height of this plane is 400 meters, and it will throw a bump and it will hit the ground. Okay, so x final here is missing. To find the horizontal distance, now we need to find the time first and substitute this time back in this one here. So y final equal y initial plus the initial y t minus half g t square minus 400, assuming that this is the origin here, equal to minus half ten t square. This is 0 and this is 0, and from this one here t equal to square root of 80 or 8.9 seconds. Now x final, that's what we are looking for, equal to x initial plus the initial x t. Now x initial is 0 and the initial x, it's 300, this right here, this one, times the t, we just calculate this one, 8.9, and you do the math for this one here, it's 2,682 meters or 2.7 kilometer. And this is the horizontal distance of the target. An object moving at a constant speed requires 6 seconds to go once around a circle with a diameter of 4 meters. What is the magnitude of the instantaneous acceleration of the particle during this time? So this is the circular path right here, and the diameter, it's 4 meters. Now, since the object is moving with constant speed, so the tangential acceleration actually is equal to 0, and the only acceleration we have is the central or radial acceleration, which is equal to v squared over r. Now x here equal to vt. Now it moves once around a circle. It means 2 pi r, the circumference of the circle is x actually, divided by the time, this is equal to v, and in this case v equal to 2 pi multiplied by, the diameter is 4, so it's 2 divided by time is 6. So v in this case equal to 2.1 meter per second. You substitute this back in the central acceleration, so acceleration equal to 2.1 square divided by 2, or 2.2 meter per second square. A particle moves at a constant speed in a circular path with radius 2.06 centimeter. If the particle makes 4 revolutions each second, this is very important here, what is the magnitude of its acceleration? Again, it's constant speed, no tangential acceleration, and the only acceleration we have here is the central, which equal to v squared over r. Now, x equal to vt, and in this case here, v equal to it's 4 revolutions, so 4 times 2 pi r divided by each second divided by 1, or equal to 8 pi times 0.02, you have to convert into meters, and the answer will be equal to v 0.52 meter per second. You substitute this back in the central acceleration equal to v squared over r, or 13.12 meter per second square. A race car moving with a constant speed of 60 meters per second completes 1 lap around a circular track in 50 seconds. What is the magnitude of the acceleration of the race car? In this case here, again, constant speed, it means that no tangential acceleration whatsoever. So A central in this case equal to v squared over r, or 3600 over r. Now 2 pi r, this is x here, equal to 60 times 50. In this way here, r equal to 60 times 50 divided by 2 pi, or equal to 477.7 meters. So the acceleration actually it's equal to 3600 divided by 477.7, or 7.53 meter per second square. At the lowest point in a vertical dive, radius equal to 0.58 kilometers, an airplane has your speed of 300 kilometers per hour, which is not changing. This is very important here. Determine the magnitude of the acceleration of the pilot at this lowest point. Now, the meaning of not changing, it means no tangential acceleration, and the only acceleration we have here is A central equal to v squared over r. Now v here, it's equal to 300 kilometers per hour, so 300 square divided by r, in this case it's 0.58. In other words, A central here equal to 155,172.4 kilometer per hour square, or 12 meter per second square. A carnival Ferris wheel has 15-meter radius and completes 5 turns about its horizontal axis every minute. What is the acceleration of the passenger at this lowest point during the ride? Now x in this case here equal to vt, and v actually it's equal to x, it's the circumference of the circle, and it completes 5 turns, so 5 times 2 pi r divided by 60, it's in a minute, so 60 seconds. So v in this case equal to 7.85 meter per second. So A central, or the central acceleration, equal to v squared over r, or equal to 4.11 meter per second square. A space station of diameter 80 meters is turning about its axis at a constant rate. if the acceleration of the outer rim of the station is 2.5 meter per second square, what is the period of revolution of the space station? Now to find this one here, A actually, or central acceleration, it's equal to V square over R, and R in this case it's 80 meters, and A equal to 2.5 meter per second square, and no tangential acceleration. So X here equal to Vt, and in this case 2 pi R, this is X, divided by V, it's the period T. So A central equal to V square over 40, and V in this case it's equal to square root of 40A, and V equal to square root of 40 times 2.5 or 10 meter per second. So the period equal to 2 pi 40 divided by 10, or equal to 8 pi or 25.1 seconds. A car travels counterclockwise around a flat circle of radius 0.25 kilometers at a constant speed of 20 meters per second. When the car is at a point A, as shown in the figure, what is the car acceleration? Now the central acceleration, we only have central acceleration because it's constant speed, which means no tangential acceleration. So central acceleration equal to V square over R, or 400, because it's a 20 meter per second, so 400 divided by the radius, it's 0.25 kilometers or 250 meters. So A central in this case equal to 1.6 meter per second square. A particle moves along a circular path having a radius of 2 meters at an instant when the speed of the particle is equal to 3 meters per second and changing at the rate of 5 meters per second square. What is the magnitude of the total acceleration of the particle? Since the speed of the particle is changing, it means there is a tangential acceleration, and a tangent in this case it's equal to 5 meters per second square. So A central it's equal to V square over R, and equal to V in this case it's 3 meters per second, so it's 9 divided by 2, the radius for the circular path, so it's equal to 4.5 meters per second square. So the magnitude for the total acceleration, so A in this case, it's equal to square root of A tangent square plus A central square, or 5 square plus 4.5 square. You do the math for this one, you will find 20.25 plus 25 right here. So A actually it's equal to 6.73 meter per second square, and this is the magnitude of the total acceleration of the particle. Now a stunt pilot performs a circular dive of radius 800 meters. At the bottom of the dive, point B in the figure right here, this one here, the pilot has a speed 200 meters per second, which at that instant is increasing at a rate 20 meters per second. This is very important here. What is the acceleration does the pilot have at point B? Now, since the speed is changing, it means the tangential acceleration is not zero, which is equal to, in this case, 20 meter per second square. So the central acceleration in this case here equal to V square over R, or 200 square divided by 800, and A central in this case it's equal to 50 meter per second square. So the acceleration as a vector equal to 20I plus 50 j meter per second square. And the magnitude for the acceleration, it's equal to square root of 400 plus 2500 or square root of 2900. So the acceleration is equal to 53.9 meter per second square. The speed of a particle moving in a circle 2 meters in radius increases at the constant rate of 4.4 meter per second square. At an instant when the magnitude of the total acceleration is 6 meter per second square, what is the speed of that particle? So again, a tangent in this case equal to 4.4 meter per second square. The radius for the circular path it's 2 meters, and the magnitude for the acceleration it's 6 meter per second square. In this case here, the magnitude for the acceleration is actually equal to square root of a central plus a tangent square. When you square both sides of the equation, you will get a square equal to a central square plus a tangent square. Now this one here, it's equal to 36 equal to a central square, which is unknown here, plus 4.4 square. In other words, a central equal to square root of 16.64, or a central here equal to 4.1 meter per second square. A central equal to v square over r, and from this one here, v equal to square root of r a central, or square root of r, it's equal to 2 given, and a central, we just calculated this one, it's 4.1, and after all, v equal to 2.9 meter per second. A car travels in a flat circle of radius r. At a certain instant, the velocity of the car is 24 meters per second west, and the acceleration of the car has components of 2.4 meters per second square east and 1.8 meters per second square south. What is the radius of the circle? So we have here a circle right here, like this one here, and at this point here we have tangential acceleration and we have central acceleration, and the speed here for the particle this way 24 meter per second. So a central here equal to v square over r, or in this case this is the central acceleration, 1.8 meter per second square equal to 24 square divided by r. You just simplify this one here, r equal to 24 square divided by 1.8, or r in this case it's equal to 320 meters, or 0.32 kilometers. A car travels in an oval path as shown below. VA equal to 25 meters per second west and VB 20 meters per second north. So the ratio of the magnitude of the centripetal acceleration at B to that at A, which is AB, divided by A is equal to. Now let's calculate the central or centripetal acceleration at A, which equal to, now this is A and VA it's equal to 25, so V square over RA, and semi-minor axis, here it's RA, and equal to 625 square divided by this radius here, it's 400, or 1.56 meter per second square. Now A at B equal to this one here, it's the velocity or the speed at B, it's 20 meter per second, it's 400, divided by this semi-major axis, it's 500, or equal to 0.8. So AB divided by AA equal to 0.8 divided by 1.56, which equal to 0.5. That's it. Thank you for watching.